Hello, my name is HongYouJun. Today I'm going to go through tutorial 4 of my engineering mathematics. So this is the question 1. The question 1 is to find the inverse matrix of A by using the Gauss-Jordan method. So first I write it into the augmented matrix with the identity matrix. Then I use the elementary row operation to solve it. So the first is I change the R1 with the negative, and negative 2R1 plus R2 equals to the new R2, negative 2R1 plus R3 equals to new R3, negative 2R2 plus R3 equals new R3, and I divide the R2 by 3 and multiply negative 1 over 9 R3 to become new R3. After that, negative 2R3 plus R2 equals to new R2, R2 2R2 plus R1 equals to new R1. Then the last is the 2R3 plus R1 equals to new R1. So the inverse matrix of A is negative 109, 209, negative 209, 209, negative 109, negative 209, 209, 209, and 109. So now I will proceed to question 2. So this is question number 2. The question number 2 is solve the following system by using the Cramer's rule. The Cramer's rule is the method substitute the answer into the base matrix, then find the determinant and divide by the determinant of the base matrix to find the answer. So in this case, I let the 2, 5, negative 1, negative 1, negative 3, negative 4, 3, negative 4, and 3 to become matrix A, and use the substitute answer to become the matrix of A1, A2, and A3. So first I find the determinant of matrix A, which is 76. Then for matrix A1, I use the substitute of the answer, which is 1, 12, negative 15. I substitute into the column 1 of the matrix A to become the matrix A1. So I find the determinant of matrix A1, which is the negative 380. Then same as A2, I substitute the 1, 12, and negative 15 into the second column of the matrix A to let it become matrix A2, and find the determinant of A2, which is equals to 2, 2, 8, and A3 like the same. I substitute the answer column into the third column of the matrix A to become matrix A3. So the determinant of matrix A3 is equals to 304. So lastly, to find the x, y, and z, I use the determinant A1, A2, and A3, all of them divided by determinant of A. So the x is equals to negative 5, y is equals to 3, and z is equals to 4. So this is question 2b. As you can see, I rewrite the equation into the matrix form. Let the 3, negative 1, 4, 2, 4, negative 5, negative 1, negative 1, and 1 equals to become the matrix B. So I find the determinant for matrix B, which is 2, and I substitute the column of the first column of matrix B into the 29, 73, and negative 18 to let it become matrix B1. So the determinant for matrix B1 is negative 50, and for B2, the method same as B1, which is I substitute the 29, 73, and negative 18 into the second column of matrix B. So the determinant for B2 is 184, and B3 like the same. It's like the same. So I substitute the 39, 73, and negative 18 column into the third column of matrix B to let it become B3. So the determinant of B3 is 98. So the answer for x, y, z is equals to negative 25, 92, and 49. So now I will go to question number 3. So this is question number 3. First, like the same, we rewrite the equation into the matrix form. And I let the 305, negative 405, 405, and 305, the matrix become matrix A. So the determinant for matrix A is equals to 1. Then for A1, I substitute the P and Q into the first column of matrix A to let it become A1. So the determinant is 3P plus 4Q over 5. So like the same, the A2 is 305P, 405Q. So I substitute the P and Q into the second column of matrix A. So the determinant of A2 is 3Q minus 4P over 5. So the solution of x and y is to let the determinant A1 divided by determinant A and determinant A2 divided by determinant A to find y. So x is equals to 3P plus 4Q over 5, and y is equals to 3Q minus 4P over 5. So this is the question number 4, to find all the eigenvalues and eigenvectors. So for matrix A, I rewrite it to minus the lambda with the identity matrix. So compared to the matrix A, the new matrix is 3 minus lambda, 2, and 2, 3 minus lambda. So for the determinant of A minus lambda I is equals to 0. So from the equation there, we can find the value of the lambda, which is the eigenvalues. So the lambda 1 is 5 and the lambda 2 is 1. So the eigenvalue is, the first eigenvalue is 5 and the second eigenvalue is 1. So for the eigenvectors, I use the A multiplied x equals to the lambda multiplied with x. So the first lambda is 5, so it's equals to 3, 2, and 2, 3 matrix multiplied with x1, x2, and equals to 5, x1, x2. So from the matrix, we can get the equation 3x1 plus 2x2 equals to 5x1, and solve it, and we can get x1 is equals to x2. So the answer, the vectors as lambda 1 equals to 5, and we can get x1 equals to 1 and 1. So the second lambda is 1, so like the same, I use the A multiplied with x and lambda 2 multiplied with x to get the eigenvectors. So from the matrix there, we can get the equation of 3x1 plus 2x2 equals to x1, and solve it, we can get x1 is equals to negative x2. So the x2 is equals to negative 1 and 1. So this is the eigenvalues and the eigenvectors. So that's all for tutorial 4. Thank you.